Time for a recap. You have learned how to add a hidden layer to the network and why this helps when dealing with nonlinear data. By now, you have seen a network that can find the relationship between x and y values, can predict car maintenance costs, can predict whether to keep or sell cars, and finally was able to predict flower colors in linear and nonlinear data. Let me show you an updated process diagram. You are looking at all the steps required to train a neural network with hidden layers. Here is the full code. You do not need to read it right now. Just get an idea of its size. I think it is amazing that just a few lines of code are capable of learning from very complex data. And if we would use a library like NumPy, we can even shrink this code to half its size. But the goal here is not to write compact code or fast code. The goal is to learn how a neural network works. And with this plain Python code, it is also very easy to port the code to another language. I have not tried it, but I see no reason the code should not run on a Commodore 64. You have seen all building blocks now. From here, we only need to make small variations to get to the ultimate goal, recognizing handwritten numbers. Oh, there might be a question on your mind after learning about hidden layers. For example, how many hidden layers do we need? The answer to this question is, just try it out. Different problems ask for different solutions. You can see the amount of hidden layers as an extra parameter in the network. Notice that adding extra hidden layers will add extra calculation time. Another question could be, how many neurons does a hidden layer have? 4? 8? 80? Again, find a good balance between extra training time and the quality of the predictions. Now that we have finished the code for the flower network, I'd like to address something I ignored so far. What happens when we let Python pick random values for the weights and biases? You will see the answer to this question in the next part.